Hi, welcome to the drawing Lewis dot structure video. In this video, we're going to look at molecules that have no central atom. And again, it may be helpful to utilize the note packets that go with this. This would be the third page of the note packet. On the left-hand side or the left column, you can show your work as you go along with this video. On the right-hand side, you can fill in the steps. You can either use the information presented in this video to help you fill in the steps, or you can use the information on the first page to help you fill in most steps, as most steps are the same. Let's begin. So we're given the chemical formula C2H6, and we're asked to draw the Lewis dot structure. The very first step is to draw the Lewis dot structure of all the atoms in the molecule. I've already started by drawing the 6 hydrogen atoms, and in a moment I'm going to draw the 2 carbon atoms. So just to recap, we use the chemical formula to find out how many of each type of atom we have. The small numbers to the right of the atom tells you what type. Okay, so here are the Lewis dot structures. Now that we have the Lewis dot structures of all the atoms, we're now going to pick a central atom, and the one with the most unpaired electrons or single dots is going to be our central. So each of these hydrogens have 1 unpaired electron. How many unpaired electrons do the carbons have? So if we take a look, we see that both carbons have 4 unpaired electrons, and we can tell that easily because the unpaired electrons are single dots here, and there's 1, 2, 3, 4 of them. Okay, so now we're kind of at a conundrum because we know that the carbons have the most unpaired electrons, or have more unpaired electrons than hydrogens, but which one's going to go in the center? They have equal number of unpaired electrons. So in this case, there is no central atom because both of these can go in this, have the most unpaired electrons. So what we do in the case where there's no central atom is we're going to connect the ones with the most unpaired electrons first. And that means we're going to connect the 2 carbon atoms with a single bond or a single line connecting their unpaired electrons first. Now that we have them connected, the next thing we're going to do is we're going to connect all the other atoms, which are these hydrogens, to the quote unquote 2 central atoms, so the 2 carbons, and we're going to try and distribute them evenly. A good way of sort of checking about distributing them evenly is to count how many unpaired electrons that you have on your 2 central atoms. So 1, 2, 3, 4, 5, 6. There's 6 available unpaired electrons. And then count how many atoms you have to attach to them. 1, 2, 3, 4, 5, 6. So they kind of match up. So that means that we can connect each atom to one of the central atoms, one of the carbons. So let's go ahead and do that. So we're just connecting. So in this rightmost carbon, I'm just sort of connecting nearby hydrogens. I'm just pairing up their unpaired electrons. I do the same thing on the left carbon. And I've got everything connected there. The next step is to check for any unpaired electrons. So we look at our structure. We see that there are no more unpaired electrons, so we can go ahead and move on to the next step. If you had a situation where you did have unpaired electrons left, then remember that would be simply you'd have to make double or triple bonds in a case like that where you had unpaired electrons left. For us, we're going to have a structure with all single bonds, so we can go ahead and move on to the next step. The next step is to clean up your structure. So what we're going to do is we're going to start by redrawing the 2 central atoms, which are the 2 carbons, and we look and see what kind of bonds are connecting the 2 carbon atoms. It's just a single bond, so I'm just going to draw a single bond between them. Then I just go around to each carbon and sort of see what type of bonds they have. So if I start on the rightmost carbon, I see on the top of it I have a carbon-hydrogen single bond. To the right of this carbon, I have a carbon-hydrogen single bond. Below it, again, I have a carbon-hydrogen single bond. And I'm just aiming to draw bonds that are going straight up and down or straight left and right. So just turning these diagonal loopy lines into straight up and down or left and right bonds. Okay, so going on to the next carbon, the one right below it, it's just a carbon-hydrogen single bond. So I draw a carbon-hydrogen single bond going straight down. To the left of this carbon, I see there's a carbon-hydrogen single bond, so I just draw a line going straight out. And then up at the top, again, there's a carbon-hydrogen single bond. I just draw one going straight out. So this is my cleaned up structure. Then I have to check for see if there are any lone pairs. There are no lone pairs here. So the hydrogens and carbons, they both do not have any lone pairs. So I can go ahead and move on. Now I'm just going to simply check for the octet rule, and we've done this many times. So I'm going to pick a carbon to look at. I'll start with one of the carbons first. I like to start in the center for some reason. I think it's just easier, but maybe you like to start in the ends. It doesn't matter. And I only need to check one of these carbons because the two carbons are exactly the same. And what I mean by exactly the same, this carbon has 4 bonds attached to it, and this carbon has 4 bonds attached to it. So since they are the same in the sense they have the same number of bonds attached, they don't have lone pairs, I only have to check one. So by checking one, I can check the other. All right, so remember, for the octet rule, we're looking to see if it has 8 electrons around it, unless it's hydrogen or boron. So I see 2 electrons in this first bond, 4, 6, 8. Each bond has 2 electrons. So this carbon is good. It has 4 bonds around it with 2 electrons in each bond. It gives me 8 electrons. Checking the hydrogens. Again, I only have to check one hydrogen because all the hydrogens are alike. They're all alike because they have a single bond attached to them. So we can go ahead and just check one, and there's one bond with 2 electrons in it, giving you 2 electrons attached to the hydrogen. So this structure looks good. It checks out for my octet rule. So the main difference in this example than all the other examples you've seen is we had a case where we did not have a central atom. There's a couple of clues that you don't have a central atom. Oftentimes the first atom is the central atom, and if there's a subscript there that is not 1, so there's a number there, in this case it's a 2, then that's a clue for the first atom, if there's a subscript other than 1, that you're not going to have a central atom. But even without using sort of that little quick trick or quick tip for recognizing the central atom or not, when you get to the step where after you draw all the Lewis dot structures of your atoms, again, the central atom has to have the most unpaired electrons. If you have 2 atoms that have the same number of unpaired electrons, or 2 or more atoms with the same number of unpaired electrons, then you don't have a central atom. You're just going to go ahead and connect those first. All right, I hope you found this video helpful. I would go on to do practice set number 3, where you sort of have a mix there of things where there are no central atoms, sometimes all single bonds like in this case, or sometimes single and double bonds. Check your answers, and yeah, have a quality day.